Okay, we're on the special sequences and series. So in this class, the special sequence series is going to be arithmetic and geometric. What do we cover? We covered arithmetic. We both covered a formula for the nth term. That's assuming we start with 1. We went through that derivation. And we also did the sum of the series, the arithmetic series. We did the geometric, a formula for the nth term, again, assuming we start with A1. And we talked about sums. We both talked about for geometric, both infinite and finite sums for that. Now we need to drive that across, that we need to be able to do problems that are related to this. All right, so what we're going to do is switch to the whiteboard, and we're going to do the examples now. Give me 1 second, and I'm going to go to the whiteboard. I got to get my cable. And I got to plug in. And then we'll start doing the problems. You know what? I think I did a bad share. New share. Oh, I see what I did. All right. There it comes. We got it. All right. So again, when I'm doing these problems over here, hopefully you've paid some attention to the lecture material and that you have, some notes down that you can rely upon. And what I mean by rely upon is you're looking at things and you're saying, gee, I think I could figure that out. So let's take a look. The first one, number 1. All right. So what's number 1? Number 1 says find a formula for the nth term of the arithmetic sequence. And they give me A1. Well, the formula's done for you. So I know that for an arithmetic sequence, that AN, I'll write this down for you, is going to be equal to A1 plus N minus 1D. So I think I can write this down. AN equals A1, which is 11, that's a given, plus N minus 1D, and D has been given to you as well as 5. I would say it's in your interest to simplify this. This would be 11 plus 5N minus 5. AN would equal 11 minus 5, which is 6, plus 5N. Of course, that answer is staring at you. Let's go to number 2. And number 2 claims this arithmetic sequence. So I'm going to, if it is, I'll certainly write down A1 is 19. And I'm looking at it, and if they say it's arithmetic, it means that there's a common difference between the two terms. And what does that look to be? It looks like it's minus 5. And let me tell you why I believe that's the case. If I see 19, it went down 5 to 14. If I see 14, it went down 5 to go to 9. If it's at 9, it went down to get to 4. And if it's at 4, it went down 5 to get to minus 1. So I'm pretty comfortable with that. So what's the formula again? It's AN equals A1 plus N minus 1D. Well, let's write this down. AN is A1, which is 19, plus N minus 1, and what's D? Minus 5. Again, we're going to simplify. 19 minus 5N plus 5, very simple. AN is 24 minus 5N. I'm seeing that right there. All right. So, we did just the first 2 examples, warm-up problems. Let's go to A3. I'll make it a bit more difficult. Maybe not. So what does it say? It says, find a formula for AN. Well, I know what it is. With the formula for AN, I've been doing this over and over again. AN is A1 plus N minus 1D. And they've given me A1. Unfortunately, they didn't give me D. They gave me A1 and A10. So let's write this down. All right, so A1 is 110. And they gave me A10 is 35. Well, I want to use this formula here to see if I can figure out what D is. All right, so 35, that's A10, would equal A1, which is 110, plus, well, what's N? Well, it's 10. So it's 10 minus 1D. Let's see if we can figure this out. 35 equals 110 plus 9D, right? I'm going to take 110 from both sides. And what would you get? 65 minus 75 equals 9D, right? Don't be alarmed. D is minus 75 over 9. So I'm going to reduce that by 3. That's minus 25 thirds. Let's write the formula down now. A1, I'm sorry, AN is A1 plus N minus 1 times D, which is minus 25 thirds. Again, it's in your interest to simplify things, and I'll go through that now with you. AN, common denominator is 3. That would be 330 minus 25N plus 25. AN, 330 plus 25 is 355 minus 25. Whoops. I got to get my eraser. It doesn't look right. We're doing all right. Go to the next page. All right, number 4. Number 4 says write the first 5 terms of the arithmetic sequence down. And this just looks weird to me. It looks the way they were giving it to me. They give me A1. That's clear as day. And then, certainly I'll write the first 5 terms down. So I'm going to use this formula here to do it. So I'm going to say A2 would be equal to A1 minus 10. Well, that seems pretty easy. If A1 is 390, A2 would be 390 minus 10, which is 380. Let's write down A3. A3 would be A2 minus 10. Well, this couldn't get any easier. It just seems like each term is just 10 less than the prior. So 370, 360, 350. All right, pretty easy. Wrote the first 5 terms down. Then the question is, what do they say? What's the common difference? Well, I'm going to say D, clear as day, is minus 10. It's going down by 10. All right. I found the common difference. Now it says write the nth term of the sequence as a function of n. What does that mean? AN equals A1 plus N minus 1 D. Let's write this down. AN, A1 is 390 plus N minus 1, and D we found to be minus 10. What does this give me? AN, 390 minus 10N plus 10, AN would be 400 minus 10N. All right, pretty easy, not that bad. All right, let's go to number 5. Number 5, it gets some sorts really confused here, but let's write it down. It says find the sum of the first 190 positive odd integers. What I would recommend is you start writing down the positive odd integers like 1, 3, 5, 7, and 9. So I'm going to write the formula down now. So AN is equal to A1 plus N minus 1D. See if we can write this down. AN, what's A1 is 1 plus N minus 1. And what's D? Well, look at the sequence. It's going up by 2. And you learned about that in Math 100. So let's write this down. AN is going to be 1 plus 2N minus 2. So AN is going to be 2N minus 1. All right, I'm pretty good at that. All right, so it says the first 190. So I just got the first 5 down. I don't want to write them all down now, but I do want to know what the last one's going to be. And that's going to be A190. Let me get my eraser out. That doesn't look right. What's A190? It couldn't be easier. It's 2 times 190 minus 1. And what's 2 times 190? Well, let's see. I guess that would be 380 minus 1, which is 379. All right, what are we doing? We're adding this together. 190 terms, right? This would be awful to put down. 1 plus 3 plus 5 plus 7 plus 9 plus yada, yada, yada. That's a lot of yadas, up to 379. Now, by the way, I'm not saying you couldn't do it this way, but we have a formula for it. And let's write the formula down for you. So the formula for S190 is, well, let's write the formula for Sn down first. It's going to be n A1 plus AN over 2. We derived that already in class. Let's see what we get over here. What's n? 190. What's A1 is 1. What's AN, which would be A190? Well, we just computed that, 379 over 2. I'm going to do some arithmetic for you. Not much arithmetic, by the way. 2, 190, whoops, and this would be 380, right? That's a 9. If you do the arithmetic, though, it's really not bad. It's 36,100. You know what? I'll go through it with you. And, 2 into 190 is 95 times 380. Let me do the longhand arithmetic for you. 380 times 95. 5 times 0, 0. 5 times 8 is 40. Really not that bad. 5 times 3 is 15, 19. Let's do the 9. 9 times 0, 0. 9 times 8 is 72. 9 times 3 is 27, 34. 0, 0, 11. Let's see, 4, 5, 6, 3, 6, 100. As we said, it's easy to do the arithmetic. They're really problems that work out beautifully. All right, let's go to the next page. And that was the question and answer there. And the next page, I guess we're doing number 6, number 7, and number 8 now. All right. Now it says find the sum of the integers from minus 30 to 80. Let's write this down for you. So A1 is minus 30. A2 is minus 29. These are integers. A3 is, what's that going to be? It's going to be minus 28, right? A4, you get bored after a while, but minus 27. And I can say yada, yada, yada. And all of a sudden we get to this thing 80. And I'm wondering what that is. What term is that? All right. I'm not saying you can't do it in your head, but I want to look at it. So what do I got? I have AN is equal to A1 plus N minus 1D. Well, AN, what's A1? It's minus 30, isn't it? Plus N minus 1. And what's D? It's going up by 1. So what's AN? AN is going to be minus 30 plus N minus 1. So AN, whoops, is going to be minus 31 plus N, or N minus 31. All right, let me write that down. So if AN is equal to 80, what would N equal? Well, look at it. You have to have 31 to 80. So what term are we talking about over here? 80 and 31, right, is going to be 111. I'll get my eraser out, and I'll put this over here now. All right, let me just erase something over here too, because it's really not essential I've done that. All right, where do they want the sum? And maybe it's going to be tough. Who knows? The sum S111, which is going to be A1 plus A2 plus all the way up to A111. Well, what's that going to be equal to? N A1 plus AN over 2. I think I can write that down. This is SN, by the way, sorry. 111. I'm sorry, I made another mistake. This is S111. 111, A1 is what? Can't remember. Minus 30. Plus 80 over 2. Let's do arithmetic. SN, 30 minus 80 is 50, right? Over 2. Yeah, looks like it might be a tough problem. I'm doing it again, and I have to erase. I'm doing 111. That's going to be 111 times 25. That's 2,500, 250, and 25. 5772. 2775. Let's look at the answer. I'm seeing it right over here. All right, let's keep going. Let's go to number 7. What's number 7? Ooh, geometric. I gotta remind myself now. Geometric. So what's geometric? I'll write this over here. This is geometric now. AN is equal to A1 times R to the N minus 1. All right. So what am I going to do now? I know A1 is 6. And I know R is 3. I got that part covered. Now, let me keep going. Write the first 5 terms down. Well, it couldn't be easier. A1 is 6. That's been given. How do we get the next term? Multiply it by 3. 18. How do we get the next term? Multiply it by 3. Well, what's 3 times 18? 30 and 24, 54. How do you next term? Multiply by 3. So 54 times 3 is 150 and 12, 162. All right, things are getting tough. What's 162 times 3? 6, 18, 3, and 4. 486. Not so bad. We got them all down. Write the first 5 terms down. And again, it's geometric. We know the formula for that as well. I just want to write terms down. All right, let me see if I can get to 8. And number 8 says, write the first 5 terms down. And I know the first term. And let's talk about the second term. And what's second term going to be? A2 is going to be, and I'm using the formula, is going to be A1 over 4. So A2 would be 256 divided by 4. And 4 goes into 256 64 times. All right, that's not so bad. All right, let's keep going. And certainly, when I say keep going, I want you to keep going. And if you keep going, you're going to eventually get to something, right? A2 is 64. Let's go to A3. A3, again, I'm looking at the formula, is A2 divided by 4. Well, that's going to be 64 divided by 4. So I'm going to claim that this looks like a very simple pattern problem. It just seems like they get the next term by dividing the prior term by 4. That's going to be 16. So I think I can write them down without using the formula anymore. And the common ratio over here, R, is just 1/4. There's going to be 4, and A5, 4 divided by 4, or 1/4 of 4 is 1. All right. And they also want to write a function down, right? The common ratio, I got this. And I'll write the nth term down now for you. So AN is going to equal A1, which is 256 times 1/4 to the N minus 1. I'm going to do something that some students find very peculiar. I'm going to simplify that. However, that is a correct answer, but I want to simplify it. And what's 256? I think it has something to do with 2. Let me tell you what I think it is. 2 to some power. 2 times 2 is 4, 8, 16, 32, 64, 128, 256. It's 8. I also want to point out that 1/4 is 2 to the minus 2. And that's being raised to the power n minus 1. Let's keep going. 2 to the 8th times 2 to the minus 2 plus 2. If you did the arithmetic on the exponents, which is the addition of exponents now, you would get 2 to the 10 minus n. All right. Look at the key. Make sure you're getting the same numbers we're giving you on the board, and we are, and we got the same form in the end. Oops, I made a mistake. I see it now because I looked at the key. I made a mistake right over here. I got to correct it. I looked at my key. You should be looking at the key too. That's minus 2n plus 2. Sorry about that. That's going to be 2. 8 plus 2 is 10 minus 2n. And I did catch my error because I looked at it. Remember, when you're doing WebAssign, particularly in exams, you might be given more than one opportunity to get the right answer. All right. So let's take a look at number 9. And I'll go to the next page, and I'll go to number 9. Number 9, whoa, they say find the sum. And this might be tough to write down. I'm going to write down sort of like term by term. And what would you get? You would get, if n is 0, you get 2 plus 2. Whoops, I went too quick. I don't want to do much arithmetic. 2 times 2 sevens plus 2 times 2 sevens plus yada, yada, yada. It does eventually stop. Where does it stop at 13? Okay. I want to claim that this is geometric. With the understanding that A1 is 2. That's pretty simple. And I'm going to claim R is 2 sevens. Right? Now, what do they want me to do? They want to find that sum. I'm going to use some formula. Let me write this down. Sn (1 minus r to the n) over 1 minus r times A1. Oh, this might be tough. 1 minus, what's r? 2 sevens. What's n? Here comes the tough part. So I'm looking at it, and someone says, I don't know what I'm looking at. You're looking at this over here. A lot of people say n is 13. It is not. This is A1. This is A2. This is A3. This is A14. If you start at 0 and you go up to 13, you have 14 terms. All right, so what's n? It's 14. 1 minus 2 sevens times A1, which is 2. All right, I got to be honest with you. A lot of students have trouble with arithmetic. Now, I'm going to say it's something you really need to work on. All right, but I'm not saying I don't have trouble with it. I'm just saying that you got to work on the arithmetic stuff. All right, it just doesn't look right to get it wrong. So I'm going to go through the arithmetic with you. And the bottom is 1 minus 2 sevens, which is 5 sevens. And when you divide by 5 sevens, it's multiplied by 7 fifths. So I get 14 fifths times 1 minus 2 sevens to the 14th power. By the way, that's the extent of the arithmetic that we'd like you to be able to do. Number one reason why is 2 sevens to the 14th power is outrageously difficult to do. However, you should be able to use a calculator and come up with a number approximately 2.80 if you use the calculator, all right? About 2.8, all right? So I'm going to say 9 is done, and I want to go to number 10 now. 10 is geometric. I do these a little differently than other people do them, but the bottom line is you do it the way you want. In the key, I do it both ways. So what I'm going to do over here is say it's rational. In other words, a ratio of integers. I just don't know what the ratio is, but I'm going to write this over here. What I do is I multiply by the pattern of repetition, and there's 3 places of repetition. So what's that pattern going to be? I'd have to multiply by 1,000. And why is it? It shifts it. I would get 3864.864. If that takes your time to think through that, please take your time to think through that. Now what do? I subtract. So I would subtract 1,000x minus x, and that's the same thing as 3,864.864 repeated minus 3.864 repeated. Well, the left side's really easy to do. What do you get? 999x. What do you get on the right side? It's not that bad. It's 3861. That repetition disappeared. What do I get now? X. What's x? 3861 over 999. 9. I am claiming this is the same thing as, and I mean exactly the same thing, as 3.864 repeating. All right, so someone says, am I done? I think you're done, but I do want to claim that this can be reduced. All right, I'm going to go through that with you. I'm going to say, looking at it, I'm going to say divisible by 3. All right, so if I did that initially, whoops, sorry about that. So x is, if you divide the bottom by 3, you would get 3, 3, 3. Let me do the top by 3. 1, 8. Let's see, 8, 7. Looks tough, right? Let's see. They're still divisible by 3. And let me put that down for you. 3. And I'll put this on the side over here into 1287. Wow, 429. It's still divisible by 3. Put this down. Let's see. 27 is with 3, but 143 multiplied by 3. All right, I'm done. That's actually the correct, simplest answer. However, I don't mind that answer at all. It's not a bad answer. All right. You can also do this by using a geometric series. I don't mind you doing that. The problem with that for a lot of students, they have a terrible time following it. And we're not trying to encourage things that are terribly difficult to follow. I think what I just did over here is easy. However, some students say they can't reduce. Actually, that's the simplest great thing you could do. But this other method's not bad if you want to try it. If you want to do the geometric series, you're still going to get the same answer in the end, which is 143/27. Thank you.